Okay, I'm going to show you two slides as worked examples for dot and cross diagrams. Okay, this is a type of format that will come up on your exam. Okay, draw a dot and cross diagram for sodium chloride. So firstly, the formula for sodium is Na. It's a metal and it has 11 electrons. All that information can be found on your periodic table, which is on the back page of the exam paper. The formula for chlorine is Cl. It's a non-metal and it has 17 electrons. Now we know that when we have a metal joining or bonding with a non-metal, then it means that ionic bonding is going to take place. Okay, so let's draw. So here's our sodium, that's our sodium nucleus. We know that sodium is in period 3, so it has 3 shells. We also know that sodium is in group 1, so it has 1 electron in its outer shell. All the other shells are full. That's 2 in the first shell, 8 in the second shell, and 1 in the third shell. Okay, now that is our starting position for sodium. Now next we look at our starting position for chlorine. So there's our chlorine nucleus. Chlorine is also in period 3, so we have 3 shells. It's in group 7, which means we have 7 electrons in our outer shell. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 electrons in total. That's spread over 3 shells, 2 in the first, 8 in the second, and 7 in the third. Now, the next thing you need to remember is that when bonding takes place, the thing that's driving it to happen is that everything really likes to have a full outer shell. It doesn't like to have half-filled shells or just 1 electron in that shell. It likes to have completely full outer shells. So the situation here is sodium has got 1 electron in its outer shell and chlorine has 7. Okay, now it's easier to lose 1 electron and find somewhere else for it to go than it is to gain 7. So sodium is going to want to lose this electron, and if we look at the chlorine, there is a space there where there is an electron missing. So what happens is the electron from the sodium moves across and becomes situated in that space in the chlorine atom that wants that extra electron. Now look at the situation we've got. We've now got sodium with a full outer shell. It's the second shell, but it's full, which is great. And we have chlorine also with a full outer shell. Now you can see which electrons were originally from which atom because I've drawn the sodium as crosses and the chlorine as dots. So it's really clear which electron on the chlorine has come from the sodium. Now when we draw ions, there's some other conventions that we need to consider. First of all, we always put square brackets around our ions. That shows us that an electron has been donated or received to form an ion. So that's what the square brackets means. And also ions of course have a charge. Now sodium has a charge of +1 because it used to be neutral. Its starting position is neutral. It has lost a negative charge, which means it is now overall positive, and because it's lost 1 negative, it's now 1 positive, and we don't need to put the number 1 up there. The plus on its own is enough because it is +1. Okay, and then the next thing to put is the charge on the chlorine ion. Okay, and that's obviously going to be minus because it has gained an electron. Okay, so the conventions are brackets and your charge, and if the charge is more than 1, you need to put the number there as well. Now we wouldn't normally bother drawing all of our inner shells. Okay, you would normally only bother drawing the outer shell. So actually in the exam it would look more like this, where we've just got the sodium outer shell with 8, of course that's the second shell. We've got the chlorine outer shell with 8, and that would be the third shell, and it's very clear which electron has been donated from the sodium. Okay, that would get you full marks in the exam. Now, our next example is slightly different. Let's have a look. Draw a dot and cross diagram for a chlorine molecule. Now, the formula for chlorine is Cl. It's a non-metal, and as before, we knew before, it has 17 electrons in its outer shell. When a non-metal joins with another non-metal, it takes part in something called covalent bonding. Now, let's draw our chlorine, our starting position. So there's our chlorine nucleus. Chlorine is in period 3, so it has 3 shells, and of course 17 electrons, 2 in the first, 8 in the second, and 7 in that third shell. So we have one space there which needs to be filled by another electron. Okay, there's our space. Now, the problem when chlorine bonds with chlorine is it only needs to get one electron from somewhere. But all the other chlorine atoms also want one electron. So no one really wants to start donating and losing 7 to get their full outer shell. So they all want to gain one electron. So how do they get round this? Well, you can't just gain one electron, so they start to do something called sharing electrons. Now let's see how we draw this. First of all, we've got our chlorine nucleus, and what I'm going to do is I'm only going to draw the outer shell. Okay, so there's our outer shell. There's our second chlorine nucleus with its outer shell, and these shells overlap so that they've got a shared area in the middle. It looks a bit like a Venn diagram. They've got a shared area in the middle. Now let's position our electrons in that shell. There's 1, 2, 3, 4, 5, 6, and then we put the 7th one in the shared area. So now that electron can be shared by the other chlorine molecule, the other chlorine atom. That other chlorine atom can count that electron as in its outer shell. Let's put the other electrons in for the other chlorine atom. 1, 2, 3, 4, 5, 6, and then that chlorine atom also puts its electron in the shared area. Now, if you count round, both of those chlorines should be happy now because each of them has equivalent to 8 electrons in the outer shell. Notice there's no brackets involved, there's no charges involved. We have a shared area with some electrons on, and the result is that we have all of our shells basically are full and have 8 electrons inside them. Okay, now I'm going to run another YouTube video which is going to have more examples. I'm not going to explain how to do them. I'm just going to quickly work through them as examples. This is the one which I've gone into in more detail. Okay.